Earliest human migrations and expansions of archaic and modern humans across continents began 2 million years ago with the migration out of Africa of Homo erectus. This was followed by the migrations of other pre-modern humans including H.heidelbergensis, the likely ancestor of both modern humans and Neanderthals. Finally, Homo sapiens ventured out of Africa around 100,000 years ago, spread across Asia around 60,000 years ago and arrived on new continents and islands since then. Knowledge of early human migrations, a major topic of archaeology, has been achieved by the study of human fossils, occasionally by Stone Age artifacts, and more recently has been assisted by archaeogenetics. Cultural and ethnic migrations are estimated by combining archaeogenetics and comparative linguistics. Early humans, Homo erectus, migrated from out of Africa via the Levantine Corridor and Horn of Africa to Eurasia during the early Pleistocene, possibly as a result of the operation of the Saharan pump around 1.9 million years ago, and dispersed throughout most of the Old World, reaching as far as Southeast Asia. The date of original dispersal beyond Africa virtually coincides with the appearance of Homo ergaster in the fossil record, and about 500,000 years after the appearance of the Homo genus itself in the first stone tools of the Old Iron industry. Key sites for this early migration out of Africa are Rilwat in Pakistan, Ubaidiyya in the Levant, and Dmanisi in the Caucasus. China was populated as early as 1.66 Maya based on stone artifacts found in the Nahuan Basin. The archaeological site of Zihudu in Shanxi province is the earliest recorded use of fire by Homo erectus, which is dated 1.27 million years ago. Southeast Asia was reached about 1.7 million years ago. Western Europe was first populated around 1.2 million years ago. Robert G. Bednarek has suggested that Homo erectus may have built rafts and sailed oceans, a theory that has raised some controversy. The expansion of H. erectus was followed by the arrival of H. antecessor in Europe around 800,000 years ago, which was in turn followed by migration from Africa to Europe of H. heidelbergensis, the likely ancestor of both modern humans and Neanderthals, around 600,000 years ago. Homo sapiens migrations. Homo sapiens seems to have appeared in East Africa around 200,000 years ago. The oldest individuals found left the marks in the Homo remains and the Homo sapiens idol that was found at the Middle Awash site in Ethiopia. When modern humans reached the Near East 125,000 years ago, evidence suggests they retreated back to Africa, as the settlements were replaced by Neanderthals. It is now believed that the first modern humans to spread east across Asia left Africa about 75,000 years ago across the Bab el-Mandeb connecting Ethiopia and Yemen. For the Near East, some of these people went east to South Asia by 50,000 years ago, and on to Australia by 46,000 years ago at the latest. When for the first time H. sapiens reached territory never reached by H. erectus. H. sapiens reached Europe around 43,000 years ago, eventually replacing the Neanderthal population by 40,000 years ago. East Asia was reached by 30,000 years ago. Archaeological and genetic data suggest that the source populations of Paleolithic humans survived in sparsely wooded areas and dispersed through areas of high primary productivity while avoiding dense forest cover. The date of migration to North America is disputed. It may have taken place around 30,000 years ago, or considerably later, around 14,000 years ago. The oldest DNA evidence of human habitation in North America, radiocarbon, dated to 14,300 years ago. has been found in fossilized human coprolites uncovered in the Paisley 5 Mile Point caves in south-central Oregon. Colonization of the Pacific islands of Polynesia began around 1300 BCE, and was completed by 1280 CE. The ancestors of Polynesians left Taiwan around 5,200 years ago. More recent migrations of language and cultural groups within the modern species are also studied and hypothesized. The African Epipaleolithic Kabaran culture is believed to have reached Eurasia about 18,000 years ago, introducing the bow and arrow to the Middle East, and may have been responsible for the spread of the Nostratic languages. The people of the Afro-Asiatic language family seem to have reached Africa in 6,200 BCE, introducing the Semitic languages to the Middle East. Further, they spread around the world. An initial venture out of Africa 125,000 years ago was followed by a flood out of Africa via the Arabian Peninsula into Eurasia around 60,000 years ago, with one group rapidly settling coastal areas around the Indian Ocean and one group migrating north to steppes of Central Asia. There is evidence from mitochondrial DNA that modern humans have passed through at least one genetic bottleneck, in which genome diversity was drastically reduced. Henry Harpending has proposed that humans spread from a geographically restricted area about 100,000 years ago. The passage through the geographic bottleneck, and then with a dramatic growth amongst geographically dispersed populations about 50,000 years ago, beginning first in Africa and then spreading elsewhere. Climatological and geological evidence suggests evidence for the bottleneck. The explosion of Lake Toba created a 1,000-year cold period as a result of the largest volcanic eruption of the Quaternary, potentially reducing human populations to a few tropical refugia. It has been estimated that as few as 15,000 humans survive. In such circumstances, genetic drift and founder effects would have been maximized, leading to a rapid racial differentiation after that date. The greater diversity amongst African genomes may be in part due to the greater prevalence of African refugia during the Toba incident. Within Africa, the most recent common ancestor shared by all living human beings, dubbed mitochondrial Eve, probably lived roughly 120 to 150 millennia ago, the time of Homo sapiens H.heidelbergensis, probably in East Africa. The broad study of African genetic diversity, headed by Dr. Sarah Tishkoff, found the San people to express the greatest genetic diversity among the 113 distinct populations sampled, making them one of 14 ancestral population clusters. The research also located the origin of modern human migration in southwestern Africa, near the coastal border of Namibia and Angola, around 100,000–80,000 years ago. Three main lines of Homo sapiens diverged. Bearers of mitochondrial haplogroup L0, a colonized southern Africa. Bearers of haplogroup L1b settled Central and West Africa, and bearers of haplogroups L2, L3, and others mtDNA remained in East Africa. Exodus from Africa. There is some evidence for the argument that modern humans left Africa at least 125,000 years before present, using two different routes: the Nile Valley heading to the Middle East, at least into modern Israel, and a second one through the present-day Bab el-Mandeb Strait on the Red Sea, crossing it into the Arabian Peninsula, settling in places like the present-day United Arab Emirates and Oman, and then possibly going into the Indian subcontinent. Despite despite the fact that no human remains have yet been found in these three places. The apparent similarities between the stone tools found at Jebelfire, the ones from Joalapuram and some African ones, suggest that their creators were all modern humans. These findings might give some support to the claim that modern humans from Africa arrived at southern China about 100,000 years BP, controversially dated at 139,000–111,000 years BP. Dating results of the lunar dong teeth, which include a right upper second molar and a left lower second molar, indicate that the molars may be as old as 126,000 years. Since these previous exodus from Africa did not leave traces in the results of genetic analyses based on the Y chromosome and on mtDNA, it seems that those modern humans did not survive or survived in small numbers and were assimilated by our major ancestors. An explanation for their extinction may be the Toba catastrophe theory. However, some argue that its impact on human population was not dramatic. According to the recent African origin theory, a small group of the L3 haplogroup bearers living in East Africa migrated northeast, possibly searching for food or escaping adverse conditions, crossing the Red Sea about 70 millennia ago, and in the process going on to populate the rest of the world. According to some authors, based in the fact that only descents of L3 are found outside Africa, only a few people left Africa in a single migration to a settlement in the Arabian Peninsula. For that settlement, some others point to the possibility of several waves of expansion close in time. South Asia and Australia. Some genetic evidence points to migrations out of Africa along two routes. However, other studies suggest that a single migration occurred, followed by rapid northern migration of a subset of the group. Once in West Asia, the people who remained south spread generation by generation around the coast of Arabia and Persia until they reached India. One of the groups that went north ventured inland and radiated to Europe, eventually displacing the Neanderthals. They also radiated to India from Central Asia. The former group headed along the southeast coast of Asia, reaching Australia probably before 55,000, but with earlier estimates placing it about 46,000 to 41,000 years ago. Some new evidence shows that the migration from Africa to Southeast Asia and Australia might have occurred between 80,000 and 120,000 years ago. The migration routes from Africa to Southeast Asia were rather multiple, and along the way of migration, the H. sapiens interbred with other species like Neanderthals, Denisovans and Homo erectus. David Reich of Harvard University, in collaboration with Mark Stoneking of the Planck Institute team, found genetic evidence that Denisovan ancestry is shared by Melanesians, Australian Aborigines, and smaller scattered groups of people in Southeast Asia, such as the Mamanwa and Negrito people in the Philippines. However, not all Negritos were found to possess Denisovan genes. Andaman Islanders and Malaysian Jahai, for example, were found to have no significant Denisovan inheritance. These data place the interbreeding event in mainland Southeast Asia, and suggest that Denisovans once ranged widely over Eastern Asia. Based on the modern distribution of Denisova DNA, Denisovans may have crossed the Wallace Line, with Wallacea serving as the last refugium. A paper by K. Prufa in 2013 said that mainland Asians and Native Americans had around 0.2% Denisovan ancestry. During that time, sea level was much lower and most of maritime Southeast Asia was one land mass known as the Lost Continent of Sunda. The settlers probably continued on the coastal route southeast until they reached the series of straits between Sunda and Sahul, the continental land mass that was made up of present-day Australia and New Guinea. The widest gaps are on the Weber line and are at least 90 kilometers wide, indicating that settlers had knowledge of seafaring skills. Archaic humans such as Homo erectus never reached Australia, although they crossed the Lombok Gap, reaching as far as Flores. If these dates are correct, Australia was populated at least 10,000–20,000 years before Europe. This is possible because humans avoided the colder regions of the north, favoring the warmer tropical regions to which they were adapted given their African homeland. Another piece of evidence favoring human occupation in Australia is that beginning about 46,000 years ago, all megafauna weighing more than 100 kilograms became extinct. Tim Flannery and others argue new settlers were likely to be responsible for this extinction. Many of the animals may have been accustomed to living without predators and become docile and vulnerable to attack. The lack of advanced tools, however, could be due to various reasons, such as the fact that they lacked the resources to make high-quality tools, that the environment they were in demanded different tools to survive, or with the increase in drift from their original ancestors. This group of people could have lost their complex tool-making. An alternative suggestion, given that the bulk of the megafauna survived until at least 15,000 BP, is that the long arid period of the late glacial maximum was responsible for these extinctions, where rather than direct predation, it was competition with humans that was the final nail in their coffin. While some settlers crossed into Australia, others may have continued eastwards along the coast of Sunda, eventually turning northeast to China and finally reaching Japan, leaving a trail of coastal settlements. This coastal migration leaves its trail in the mitochondrial haplogroups descended from haplogroup M and in Y chromosome haplogroup C. Thereafter, it may have become necessary to venture inland, possibly bringing modern humans into contact with archaic humans such as H. erectus. Recent genetic studies suggest that Australia and New Guinea were populated by one single migration from Asia as opposed to several waves. In these single migration, a population which had split from the ancestral Eurasian population before Asians and Europeans split each other, reached Australia and Melanesia between 62,000 and 75,000 years before present. The descendants of the earlier migration became assimilated or replaced by the later dispersing populations from the next migration waves, with a few exceptions that include Aboriginals, Australians and other related populations like Papuans. The land bridge connecting New Guinea and Australia became submerged approximately 8,000 years ago, thus isolating the populations of the two land masses. Europe is thought to have been colonized by northwest-bound migrants from Central Asia and the Middle East, as a result of cultural adaptation to big game hunting of subglacial steppe fauna. When the first anatomically modern humans entered Europe, Neanderthals were already settled there. Debate exists whether modern human populations interbred with Neanderthal populations, most of the evidence suggesting that it happened to a small degree rather than complete absorption. Populations of modern humans and Neanderthal overlapped in various regions such as in Iberian Peninsula and in the Middle East. Interbreeding may have contributed Neanderthal genes to Paleolithic and ultimately modern Eurasians and Oceanians. An important difference between Europe and other parts of the inhabited world was the northern latitude. Archaeological evidence suggests humans, whether Neanderthal or Cro-Magnon, reached sites in Arctic Russia by 40,000 years ago. Around 20,000 BC, approximately 5,000 years after the Neanderthal extinction, the last glacial maximum took place, forcing northern hemisphere inhabitants to migrate migrate to several shelters until the end of this period. The resulting populations, whether interbred with Neanderthals or not, are then presumed to have resided in those hypothetical refuges during the LGM to ultimately reoccupy Europe, where archaic historical populations are considered the descendants. An alternate view is that modern European populations have descended from Neolithic populations in the Middle East that have been well documented in this area. The debate surrounding the origin of Europeans has been worded in terms of cultural diffusion versus demic diffusion. Archaeological evidence and genetic evidence strongly support demic diffusion, that of populations spread from the Middle East over the last 12,000 years. A scientific genetic concept called the time to most recent common ancestor (TMRCA) has been used to refute the demic diffusion in favor of cultural diffusion. Migration of the Cro-Magnons into Europe. Cro-Magnon are considered the first anatomically modern humans in Europe. They entered Eurasia by the Zagros Mountains around 50,000 years ago, with one group rapidly settling coastal areas around the Indian Ocean and one group migrating north to steppes of Central Asia. Modern human remains dating to 43–45,000 years ago have been discovered in Italy and Britain, with the remains found of those that reached the European-Russian Arctic 40,000 years ago. Humans colonized the environment west of the Urals, hunting reindeer especially, but were faced with adaptive challenges. Winter temperatures averaged from -20 to -30 degrees Celsius while fuel and shelter were scarce. They traveled on foot and relied on hunting highly mobile herds for food. These challenges were overcome through technological innovations, production of tailored clothing from the pelts of fur-bearing animals, construction of shelters with hearths using bones as fuel, and digging of ice cellars into the permafrost for storing meat and bones. A mitochondrial DNA sequence of 2 Cro-Magnons from the Palici cave in Italy, dated to 23,000 and 24,000 years old, identified the mtDNA as haplogroup N, typical of the latter group. The inland group is the founder of both North and East Asians, Caucasoids and large sections of the Middle East population. Migration from the Black Sea area into Europe started sometime around 45,000 years ago, probably across the Bosphorus and along the Danubian corridor. By 20,000 years ago, the whole of continental Europe had been settled. Competition with Neanderthals. The expansion of modern human population is thought to have begun 45,000 years ago, and may have taken 15,000–20,000 years for Europe to be colonized. During this time the Neanderthals were slowly being displaced. Because it took so long for Europe to be occupied, it appears that humans and Neanderthals may have been constantly competing for territory. The Neanderthals had larger brains, and were larger overall, with a more robust, heavily built frame, which suggests that they were physically stronger than modern Homo sapiens. Having lived in Europe for 200,000 years, they would have been better adapted to the cold weather. The anatomically modern humans known as the Cro-Magnons, with widespread trade networks, superior technology and bodies likely better suited to running, would eventually completely displace the Neanderthals, whose last refuge was in the Iberian Peninsula. After about 25,000 years ago, the fossil record of the Neanderthals ends, indicating that they had become extinct. The last known population lived around a cave system on the remote south-facing coast of Gibraltar from 30,000 to 24,000 years ago. A 2010 study of Neanderthal genes and modern human genes concluded that interbreeding took place between Neanderthals and Homo sapiens between roughly 80,000 to 50,000 years ago in the Middle East, resulting in Europeans and Asians having between 1% and 4% Neanderthal DNA, while sub-Saharan Africans do not have Neanderthal DNA. Comparison of remnant Neanderthal DNA has shown that this 4% is not consistent, suggesting that there was not one, but several cases of interbreeding between the two species, with Caucasian and Balkan DNA contributing more to the Eurasian human lineage than the archaic groups. Three-part origin of modern Europeans. Evidence published in 2014 from genome analysis of ancient human remains suggests that the modern native populations of Europe largely descend from three distinct lines: hunter-gatherers who lived 45,000 years ago and most probably originated in the second human migration out of Africa into Europe, early agriculturists who moved into Europe about 9,000 years ago and mixed in, and finally a population of Pontic-Caspian steppe nomads who contributed DNA to a wide range of modern humans including Native Americans, Central and Northern Asia. Mitochondrial haplogroups A, B and G originated about 50,000 years ago, and bearers subsequently colonized Siberia, Korea and Japan by about 35,000 years ago. Parts of these populations migrated to North America. A Paleolithic site on the Yana River, Siberia, at 71 degrees north, lies well above the Arctic Circle and dates to 27,000 radiocarbon years before present. During glacial times, this site shows that people adapted to this harsh, high-latitude, late Pleistocene environment much earlier than previously thought. America's Paleo-Indians originated from Central Asia, crossing the Beringia land bridge between eastern Siberia and present-day Alaska. Humans lived throughout the Americas by the end of the last glacial period, or more specifically what is known as the late glacial maximum, no earlier than 23,000 years before present. The details of Paleo-Indian migration to and throughout the American continent, including the dates and the routes traveled, are subject to ongoing research and discussion. Dates for Paleo-Indian migration out of Beringia are a matter of current debate. Estimates range from 40,000 to around 16,500 years ago. The routes of migration are also debated. The traditional theory is that these early migrants moved when sea levels were significantly lowered due to the Quaternary glaciation, following herds of now extinct Pleistocene megafauna along ice-free corridors that stretched between the Laurentide and Cordilleran ice sheets. Another route proposed is that, either on foot or using primitive boats, they migrated down the Pacific coast to South America as far as Chile. Any archaeological evidence of coastal occupation during the last ice age would now have been covered by the sea level rise, up to 100 meters since then. The recent finding of Australoid genetic markers in Amazonia supports the coastal route hypothesis.